WSD and the International Space Station, an adventure in science. In September 2017, WSD students had the chance to take part in the Student Spaceflight Experiments Program, run by the American-based National Center for Earth and Space Science and the International Arthur C. Clarke Institute for Space Education. The program offered the opportunity of a lifetime. A select group of student teams had the chance to launch their science projects into space with the assistance of astronauts aboard the International Space Station.
Power and telemetry nominal.
What we wanted the students to experience was a really authentic research process that scientists go through.
In the fall of 2017, 560 grades 5 and 6 students began their research for the project. 16 WSD schools and 24 classrooms were represented.
Who can tell me what microgravity is?
It's a small amount of gravity.
Very good. So that's a really good way in science to understand some of the big words that we see, right? Micro means small. Gravity means the force of gravity, right? It's a force. Who can explain to me what the force of gravity is?
Initially at the start of the program, what we did was we brought all of our classes into the Inner City Science Center and we had them all work through a problem about nutrition. And so how we presented that to the students was that we said, okay, you're an astronaut up in space. You could be in space for a very long mission. Okay, so we weren't even thinking just of International Space Station. We were thinking beyond to some of our next missions, like to Mars. And we were talking about what would be some of those constraints that you would have as an astronaut traveling these long distances. And so one of the most common kind of themes that came up was food.
It's important to explore space and see what else is out there. And the astronauts need to be healthy and fully charged to do that.
Student teams ultimately submitted 87 different experiment proposals. A local panel of science professionals, professors, WSD educators, and community members selected 3 finalist teams from Grosvenor, Lord Nelson, and Wolseley schools. The National Center for Earth and Space Science convened a board to review the American and Canadian finalists. They ultimately chose projects from Grosvenor and Wolseley to be launched into space. Lord Nelson students would get to present their project at the Smithsonian Air and Space Institute in Washington, D.C. Both spacebound projects examined plant growth and microgravity. Grosvenor's project studied the growth of lacinato kale.
Kale is very healthy. It has the vitamins of A, K, E, and B1, B2, B3, and B6. It has so much vitamin, good stuff, and calcium. It has more oranges and milk are known for vitamin C and calcium. So kale actually has more vitamin C than orange and more milk, and more calcium than milk.
The second finalist project, from Wolseley School, examined the germination of yarrow and microgravity.
We thought of yarrow because yarrow has medicinal properties. The indigenous people have used it for a very long time. It can cure hay fever and headaches by making yarrow into a tea. It can cure toothaches by chewing on the fresh leaves, and it can cure wounds by making yarrow into a tincture, which is kind of like a cream, and you can put it on the open wound, which can help it heal faster.
Due to the enormous costs of sending materials into space, all 30 student science experiments aboard the SpaceX Falcon 9 launch vehicle and Dragon cargo spacecraft had stringent size requirements. Each experiment had to fit in a small capsule known as an FME, or fluid mixing enclosure. Each experiment was also subject to tight time constraints.
It had to start and stop in space, which was a struggle, which means we had to figure out where to put the water and the soil and the seeds so that the astronauts could unlocked chamber so that the water and the soil would connect with the seed, but they had to do it in space. So in other words, it couldn't be growing when we sent it off to go to Cape Canaveral, and it had to end in space, which means when it came through the, when it came back down to Earth, it's not like we could just stop it right there and pour the salt in. We had to stop it in space, which means we had to have our own, we were given 3 compartments, we had to have our own compartment dedicated to the material or whatever we're using to stop our experiment.
Students and educators from both the Grosvenor and Wolseley teams traveled to Cape Canaveral, Florida for the launch of the SpaceX Falcon 9 two-stage launcher and the Dragon cargo vessel.
The Dragon spacecraft launching on today's mission was created with one on SpaceX's Science Program mission.
Right before we went up, it was like building tension, like, oh my gosh. And then we started the countdown, and let's just say everybody started going ballistic.
10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Ignition, liftoff.
You could feel it in throughout your whole body. You could hear the rocket launching. You could see everything happening. We were getting emotional. We were crying. I mean, there was a piece of us, a piece of Winnipeg School Division up on that rocket that was eventually going up to the International Space Station. Just like that.
As you saw, we had a successful liftoff of the Falcon 9. If you were watching closely, you also saw the strong back retract just during.
And the idea that our project from our garden is going to be flying in space over our heads, it's astronomical to even think about.
Incubation was greater on Earth or in space.
On August 28, 2018, the Grosvenor and Wolseley teams met at the Inner-City Science Center to inspect the contents of their fluid mixing enclosures, which had recently returned from space. Seeds from both experiments germinated in space.
But all 4 of the seeds germinated and 3 of them actually sprouted.
The one that came back from the space station, we analyzed it and it was 6 out of 10 that germinated.
The teams will be comparing the results to a second set of seeds grown on Earth in the same time span as the cohort in space. Both student groups said their respective superfoods warrant further investigation for use on space missions.
And the purpose of our experiment is to have astronauts healthier and living better lifestyles.
Along with creating memories that will last a lifetime, the long-term project has built lasting student connections to science.
Through the experience that I had this year, actually, with my whole class doing these projects, majority of them that weren't even interested in science have said now that they're interested in science.
When we think of career education, we think about grade 9 to 12 students looking at the kind of career they want to take and what courses they're going to take. But what we find in the research is that a lot of students form their interests and they form kind of positive connections with certain subject areas quite early on. So grade 5 and 6 is one of those really great target areas where we can start to cultivate that interest in the sciences and in the STEM fields with students.
There's so much more out there than we see in the normal day.
and some of it could end up being useful.
There's so much to learn out there that we don't know.
This group of kids, now they got that experience of having that hands-on, seeing the whole process and what it entails doing a science experiment. There's a lot of details that have to be done, and they're still like gung-ho and really excited and want to, continue in that science direction going further in their education. So it's pretty exciting and it's a great experience.